students, I am your Mahima teacher. Shouldn't we continue the effort that has to become the Agniveer AIRFORCE? So let's start our section with another new question. The excess pressure in a soap bubble of the radius r is proportional to. The options are 1 by r, 1 by r square, r square. Then let us derive the excess pressure inside the soap bubble. We know that a soap bubble, we all see the soap bubble, but we don't know how much surface are there. There are two surfaces. First, the surface, one is inside the soap bubble and another is outside the soap bubble. Therefore, the soap bubble has two surfaces. Okay, then in soap bubble, the molecule present in the surface film will experiences the surface tension. Due to the surface tension, the soap bubble contracts. Soap bubble reduces its surface area, so that the pressure inside the soap bubble is maximum. It is greater than the pressure outside the soap bubble. Let us discuss how much it is. Let Pi is the pressure inside the soap bubble and P0 is the soap pressure outside the soap bubble. Okay, then here we can see that the Pi is greater than P0 and there is delta P is equal to Pi minus P0 is the excess pressure. It is the excess pressure. In order to derive the excess pressure inside the soap bubble, first consider the work done to expand the bubble. Due to the pressure, high pressure inside the soap bubble, this surface area increases little much. And that is considered, it is about dr distance, it is displaced dr distance. And the radius of that bubble is considered as r. Then the work done by the excess pressure inside the soap bubble to increase or to displace the surface by dr amount, it is W, and W is equal to the excess pressure into the surface area. What is the surface area of the sphere? It is 4 pi r square into displaced distance, it is dr. This is the total work. This work is converted into what? Now we know that work energy theorem. The work is converted into potential energy. This work has to increase the potential energy of the bubble. Let us consider delta U is the potential energy, the increasing potential energy. And its expression is like that. The potential energy, it is equal to, the surface tension into increase in the surface area. Increase in the surface area, which is equal to T into increasing. What is the initial and final surface area of the bubble? The final surface area, the total radius is r plus dr. Initially, it's only r. Therefore, T into 4 pi r plus dr whole square minus 4 pi r square. The final area minus initial area. But we have to multiply a constant, that is 2, because it has two surfaces. Therefore, this equation into 2t into 4 pi r plus dr whole square minus 4 pi r square. Then we have to expand this term, this bracket term, then the 2t into 4 pi, here a plus b whole square, formula a plus b whole square, it is r square plus 2r dr plus dr square, and then bracket is closed, then minus 4 pi r square. Here the 4 pi r square and 4 pi r square are cancelled each other, and we neglect this term because dr is very small term with a small number, and if we square it, is much less than that value, initial value. So we have to cancel both of this, r square as well as dr square. So finally, the increase in potential energy is equal to 2t, here 4 pi, and another term is 2r dr. And this increase in potential energy must be equal to this work done. Therefore, work done is equal to increasing potential energy, which is equal to delta P into 4 pi r square dr equal to 2t 4 pi 2r dr. And here the 4 pi are cancelled each other, and r square, here only one r, therefore it cancelled each other, and dr they cancelled. Finally we got an answer like this. Delta P, the excess pressure, is equal to here the 4 T and by R. The excess pressure is equal to 4T by R. What is T? It is the surface tension. R is the radius. That means the excess pressure is proportional to the surface tension and inversely proportional to the radius. So our correct answer is option A. Let us wind up this section. Thank you. See you on another section with a beautiful question. Bye.